A very good morning again, guys. My name is Jahil, and as you all know that currently we are solving LeetCode problems, and today we are going to solve a LeetCode problem related to the linked list. And in this problem, we are going to uh, look after the solution about the question if the linked list has a cycle or not. So we'll just move to the LeetCode, and the question name is linked list cycle. Okay, so you can see that the question number is problem statement 144, and it is given that it is a very easy level question. And talking about the description, we are given the head of the linked list, and as you all know, head it refers to the very first node in a particular linked list, and we have to determine if linked list has a cycle in it. So there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. It means that let's just say in our given linked list there is a node X. Okay, so the next of the node X will be previous of some given node, and let's just say the another node is Y. So if the next of node X is a previous of node Y, then we can say that it has a cycle. uh, and the wordings, as you can see, that it completely makes sense. And what we have to do is that we have to return true if there is a cycle in linked list, otherwise we have to return false. So here we are given the problem statement, and we have to return the result in form of a boolean. And here in this first example, we can see that the input is 3 2 0 and -4, and the position is 1. So output is true, and there is a cycle in the linked list. And talking about how we found a cycle in the linked list, let's just say that first what we'll do is that in this problem statement, the one of the best method is to use two pointers. So we'll use a slow pointer and a fast pointer, and we will move slow pointer one step and we will move fast pointer two step. And whilst moving the fast pointer, what we will do is that we will check if slow equals to fast. It means that if they both are same somewhere in the our loop, unless and until there the fast pointer is not null. And and if they are same, then what we'll do is that we will simply return true, because it will make sense. There will be a cycle in the linked list. So let's just try writing the code. And first what we will do is that we will take slow pointer uh, as head, and we'll also do the same for fast pointer from head. And now we will use a while loop. And in while loop, let's just finish writing the while loop, then I'll explain why we wrote two conditions. The reason why I wrote while fast is not equal to null, and the next of the fast is not equal to null, is because as you know that we are moving fast pointer two steps. So it's like an edge case. We can say that we have to check both the conditions for the fast pointer if we want to get our perfect results, because fast pointer it moves two steps, so its next can also be null, and the fast pointer it can also get null somewhere. So to make sure that we iterate from the start to very end without missing any element, we will give both the conditions. And what we'll do is that we will move the slow pointer as the next of the slow, and fast pointer will be Okay, so inside this while loop, we have written the condition for slow and fast. And what we will do is that we will simply check if both the pointers, if they meet somewhere, then what we will do is that we will return true. And outside of the while loop, if both of them, they don't matter, they don't uh, meet anywhere, then we will simply return false. And what we'll do is that we will try running this again. And so you can see that we have passed all the test cases. And for the case 2, the head is 1 2 and position is 0, and output is also true, because we will look after the dry run also. And here we can see head 1 and position -1, so it's obvious that there is no cycle because there is only one element in the linked list. Now talking about the dry run, let's just say that we have an example 3 2 0 and -4, the first example. So what we'll do is that our slow pointer and fast pointer, they both will start from the head, that is 3, and we will move slow 1 step and we will move head 2 steps. So in first iteration, our slow pointer will be at 2 and our fast pointer will move 2 steps, so it will be ahead and it will be at 0. And in second iteration, our slow pointer will be at 0 and our fast pointer will be at -2. So so far, after 2 iterations, they haven't matched yet. But when we talk about third iteration, in third iteration our slow is at 0, so our slow will be at -4 and our fast was at 2, so our fast will move 2 steps ahead. So 2 will also move to -4. And we can see that in our third iteration, both the slow and the fast pointers, they are meeting at this -4. And if we talk about more defined manner, here we can see that initial state is 0, slow is at 3, and fast both are at 3 head. And slow will be at 2 and then fast will be at 0. And then just like that, fast is moving 2 steps ahead. So it's obvious that at some point the fast and the slow pointer will meet, and we can see in iteration 3, slow and fast both are meeting at -4. So that was it for today's guys, and we easily learned how to detect if there is a cycle in a given linked list or not using 2 pointers. And it is a very easy question. I hope you guys understood the question. Subscribe for more videos, and thanks for watching.